Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Hi, everybody. Tonight I'm going to do the review for test 4. Boy, I got to get to that finger fix. But anyways, boy, where did this semester go? Wow, it's almost May, almost the end of the semester. All right, test number 4. Let me remind you, let's go to D2L. And if you look on D2L, you'll see this Thursday, the 1st of May, I will be giving test number 4 online. You'll have on Thursday morning, 8 o'clock or earlier, like I've done all semester, I will send out an email with the password for test number 4 PDF file, which you will download from the assignment area of D2L. You'll have until Friday, the 2nd of May, 8 p.m. to finish your test number 4 and upload your answers to the assignment area of D2L as a single PDF file, please. It should take about 40 minutes if we were face-to-face, but hey, take as long as you need, as long as you get it uploaded on time. Test number 4 will cover polymers, lipids, and carbohydrates. Wow, this is a fattening test. But anyways, test number 4 has 9 pages, 20 problems. Some of the problems have multiple parts. I have never and never will give a multiple choice question on a test or a final in 170. Also, here's the point breakdowns for test 4. General now, 54 points, yes, 54 points. Nomenclature, 15, reactions, 36. So there's five bonus points. Now, why so many points general knowledge? Well, if I were to ask on a test, is your left foot chiral or achiral? Well, that's not nomenclature. That's definitely not reactions. So it must be general knowledge. That's why there are a lot of general knowledge points, because there's a lot of information that only fits in general knowledge. All right, again, this test won't be open notes, and I'm doing the review right now. All right, let me also remind you that, first of all, the extra credit project, which is optional, the deadline is this Thursday, 11:59 p.m. So you have until Thursday to do it. Before Thursday, you can always email me your project and I'll check it and tell you if something's wrong that you need to fix. And I'll help you. Now, one misconception for the project has been you need 10 different functional groups, molecules. No, you can have alcohols or ketones or whatever, any mix, as long as it's one ingredients found on a label. So you can't talk about the ester in a banana, because I've never seen that name on an ingredient list of a banana. And 2, it's got to be a functional group we've talked about in Chem 170. When students in the past have used functional groups that we didn't talk about, they always got it wrong. And that's not good. All right, the other thing I wanted to remind you, lab amnesty. The lab points are important for your grade, and they're not that hard. And you have until Thursday, the 8th of May, at the end of the day, to submit any labs that you have not submitted that are late. So please submit all your labs. I'll grade them. Since COVID, there's something going on that students have been late or forgetful about labs. Go to the grade book in D2L if you don't have a number there. And if you handed it in, email me and let me know, so I'll grade it. And if you had any labs, email me and let me know, so I will grade it. All right, one other thing I want to show you that's very important. If we go to content and we're in the lecture section of content right here, lectures, if you scroll all the way down, you'll see this button right here that says load more. And you have to click it, left mouse click, which I'm going to do right now. And now you can see chapters. And the most important thing is test 4 review. And I will be going through test 4 review with the Word document. It's also available as a PDF document. All right, let's get going. All right, first part on test 4 review. And again, this file is in the lecture section of the content of D2L. And you have to click on the load more to get to that part where they have it. So let's talk about what is a polymer. And a polymer is a macromolecule, that means a big molecule, made up of repeating units called monomers. Think of it like a very long freight train of boxcars and other kind of cars. Now, you should know that there's two ways of distinguishing polymers, one by their chemical property, the other by a physical property. And the chemical property you should know, an addition polymer is a polymer with only one type of monomer. And examples of that would be rubber tires, like car tires, or the saran wrap, the plastic wrap you use in your kitchen. At least I do. I don't use saran wrap. I get mine at Costco. Theirs is pretty good. But anyways, the other type is condensation polymer. And those are polymers with two or more different types of monomers. An example of that would be this plastic. It's a polyester. Good excuse to show that so I can get a drink of water. Or a nylon jacket. No, I'm not going to bring mine up from my closet downstairs. All right, the other way of classifying polymers is by a physical property. And the first type is a thermoplastic polymer. And you should know that a thermoplastic polymer, once formed, it can be reheated and reshaped. An example of this is my plastic water bottle or saran wrap. In other words, you can recycle it. Now, the other type is a thermoset polymer. And once formed, it's a polymer once formed, it cannot be reheated or reshaped. And example of that are car tires, rubber tires, or urethane foam. Dr. White's worked with urethane foam. I think I have about 6 US patents in urethane foam. So I know that a little bit. All right, let's move on. The next area I talked about were fats and oils, otherwise known as lipids. And a lipid is a molecule from a plant or other living things like us that are soluble in nonpolar solvents and not in water. Now, there are two types of lipids you should know. The first type is a saponifiable lipid, also known as fats and oils. And what is a saponifiable lipid? It's a lipid that yields carboxylate anions of fatty acids in the reaction of a base and water, like sodium hydroxide. And a non-saponifiable lipid, also known as our steroids, do not react with base and water. So if a lipid reacts with base to give carboxylate anion of fatty acids, It's a saponifiable lipid, otherwise known as fats and oils. Now, when we talk about fats and oils, you should know that a fat is a solid or semi-solid at room temperature, 72 degrees F, or no, 75 F, and an oil is a liquid triglyceride at room temperature. What's a triglyceride? Well, in fats and oils, you have this structure. And if you remember, hopefully you have from test 3, fats oil chemists, which I have been, and we're not talking about petroleum, that type of oil, we're talking fats and oils like vegetable oil. And instead of writing an ester this way, fats and oil chemists write it this way. And if you look at the triglyceride I have here, there are 3 esters. 1, 2, 3. And that's a triglyceride. All fats and oils have that structure. What's different is R prime, and R double prime. And good news, all the reactions I taught you about esters, fats and oils undergo. Now, the first one you should know is acid hydrolysis of fat or oil. And remember, for test 3, you take an ester, acid, H+, and water, you'll get an alcohol and the carboxylic acid you would have used to make that ester. Well, with this triglyceride, first ester gives this alcohol plus this carboxylic acid. Second ester gives this alcohol plus this carboxylic acid. And the third one gives this alcohol and this carboxylic acid. And this is called glycerin. And I worked for a company for a number of years where I was laboratory manager, where by this reaction, we made glycerin, and these carboxylic acids that come from fats and oils are called fatty acids. Now, you can also have base hydrolysis, otherwise known as saponification of an ester. And here I'll use sodium hydroxide and water, sodium hydroxide and NaOH, as our base. And here we have an ester. You get back the alcohol you would have used to make that ester, but the carboxylic acid in the presence of base makes the carboxylate anion. That's important. Remember, in the presence of base, you get the carboxylate anion of the carboxylic acid you would have used to make that ester. So we have 3 esters. First ester, this alcohol and this carboxylate anion. Second ester, this alcohol and this carboxylate anion. And the third, this alcohol and this carboxylate anion. Now, one we haven't talked about, but at the company I worked at, we use to the tune of about 2 to 3 million pounds a week of fats and oils, mainly fat. If you use steam. Now, steam, high pressure steam, is very hot water. And there are 2 ways of catalyzing or making a reaction go fast. One is use a catalyst. The other is, for most reactions, not all, but this one is true, you increase the reaction temperature. So instead of using acid and water, use hot water. And you take an ester and you get back the alcohol and the carboxylic acid you would have used to make that ester. Therefore, you have the 3 esters, you get glycerin for each of the esters reacted, and each ester gives this carboxylic acid, otherwise known as a fatty acid. And like I said, I work for a company that ran this reaction at about 2 to 3 million pounds a week, every week of the year. Now, these carboxylic acids are called fatty acids. And the 2 I would like you to know, hold on, it's time for Dr. White to be subtle. Hint, know this. See how subtle I can be? The first one is stearic acid. That's 18 carbons. Notice the bracket with the CH2 inside is repeated 16 times. And this is an easier way of writing it. And stearic acid has 18 carbons and only carbon-carbon single bonds. And oleic acid has 18 carbons, but at carbon 9, this is 1 plus 7, that makes this 9, there's a double bond. And then you have 8 more carbons. So there's a total of 18, but you have 1 double bond in oleic acid. And that double bond can be cis or trans. Now, stearic acid is called a saturated fatty acid because there's only carbon-carbon single bonds. Oleic acid is an unsaturated fatty acid because there's at least 1 carbon-carbon double bond. Now, those come from the triglyceride, fat or oil. And you should know a saturated fat is a fat that has only carbon-carbon single bonds. It still has a carbonyl in the ester, but we're talking about carbon-carbon single bonds. Unsaturated fat has at least 1 carbon-carbon double bond. Now, since I worked in the industry, I'm going to teach you some stuff that's not in the book or is not correctly in the book, if you had the book, and that is you should know tallow is beef fat, and yellow grease is its quality of pig's fat, and white grease is a lower quality of pig's fat. And the company I worked for would buy 2 to 3 million pounds of tallow, yellow grease, white grease. If we get yellow grease, white grease, we'd buy that because that was about 2 or 3 cents a pound cheaper. And if you're buying 100 million pounds, 2 or 3 cents a pound makes a difference. But tallow is more readily available. Now, to do a real world understanding of what is tallow, yellow grease, and white grease, I came up with the following triglyceride, where one of them is a sterile group, this carbonyl plus the carbons in R sub S, 18 carbons, carbon-carbon single bonds only. R sub O is an allyl group with this carbonyl carbon and the carbons in R sub O. There is 18 carbons, but a double bond at carbon 9. And this is a good representation because how do you do 3 things 50-50? You can't really. So it's a combination. So therefore, if I were to ask on a test, give the reaction products for tallow and sodium hydroxide and water, what do you do? And if I also be nice enough to tell you there's 3 products, well, tallow and white grease and yellow grease is really this compound. And it's a triglyceride. And if you add base and water, you get this glycerin from R sub S, this carbon ester. You would get this carboxylate anion where the R group is R sub S. And from this ester, you'd get this carboxylate anion where it's R sub O. Now, since we never balanced an equation in this class, you didn't have to put a 2 in front of the sodium stearate. That's this right here. You should also know how to do these reactions with acid and water, base and water, which I just did, and steam. It's the same thing I did up here, except you now know one of these is R sub S, the other is R sub O, and R sub S. Now, important thing you should know, hint, big hint, hint, real big hint, know this. You should know, leaving my class, how does soap work? Well, you should know the structure of soap. Nonpolar tail, polar head, like sodium stearate. And you should know that dirt and grease are nonpolar and water is polar. And the most important part, the key to the puzzle, how does soap work, is like dissolves like. And like dissolves like means something that's polar or soluble polar things, something that's nonpolar is soluble only in nonpolar things. Well, dirt and grease, and there's an E missing at the end of grease. I tell you, I was always first one down in a spelling bee. Well, they're nonpolar. So if you have dirt and grease on your clothes, your hands, water doesn't get it off that well. And that's why you use soap. Now, we had a little particle of soap or dirt, and you use your soap. The dirt is nonpolar and attracts the nonpolar tail. The polar head wants to stay away from the dirt and is on the outside. And this totally surrounds the dirt particle with soap molecules lined up that way. And you should know that forms a micelle. Now, when water comes along, it looks at the micelle and only sees the polar heads that are surrounding the dirt and says, oh, micelle, you're polar, I'm polar. Let's go down the drain together because like dissolves like. And they do. So you should know this. Again, soap is nonpolar tail, polar head. Grease and dirt are nonpolar, water is polar. The key to this, and when I'm if you watch the videos, and if we were face to face in a classroom, I'd write it super big, like dissolves like, because that's the important thing, the key. And because of that, you form a micelle with dirt and soap, and it now looks polar to water and goes down the drain. All right, now we talked about non-saponifiable lipids, otherwise known as the steroids, also known as your hormones, and they all have this four-ring skeleton. Six-membered ring fused to a six-membered ring next to it, up here, six-membered ring, then a five-member ring. I will ask you to know how to draw the ring skeleton for a steroid. I'll say that again. I will ask you to be able to draw the ring skeleton for a steroid. All right, let's move on to something tasty, carbohydrates. And a carbohydrate is a polyhydroxyaldehyde or polyhydroxyl ketone. Poly means many, hydroxyl, OH on a carbon alcohol, ketone or molecule that upon hydrolysis becomes a polyhydroxyl aldehyde or polyhydroxyketone. Now, when we talk about carbohydrates and especially sugars, it's important to talk about chirality. And you should know chirality is Greek for handedness. And when we talk about chirality, there are two types of objects. A chiral object, achiral object, and a chiral object. Now, achiral, the A means without handedness, and that's an object with a superimposable mirror image. Now, a chiral object is an object with a non-superimposable mirror image. And you should be able to identify objects in our daily life that are chiral or achiral. Now, hint, if you can say it's right or left, it's chiral because you know already it has handedness. And see my hands? if I took my ring off, which I won't because I never do, uh, my hands are mirror images, but they're not superimposable. If I get my center finger lined up, my thumbs are in the wrong place. If I get my thumbs lined up, none of the other fingers. And therefore, your hands are mirror images, non-superimposable. You know I got to do this. Know what that is, don't you? A spider doing push-ups on a mirror. I told you I had to do it, and I did. Now, when it comes to molecules, it's important to know what is a chiral carbon. And a chiral carbon is a carbon with 4 different groups or 4 different atoms or a combination of 4 different groups or atoms. And that's chiral. And we talked about this in the video, how to find it. If a carbon has 2 or more of the same group, or if it's in a double bond with carbon or oxygen or anything else, nitrogen, a triple bond, it can't be chiral. So if it has 2 or more of the same group, or if it's in a double or triple bond, that carbon cannot be a chiral carbon. Now, I talked about enantiomers, and enantiomers are the non-superimposable mirror image of a molecule. And if I were to ask, draw the enantiomer or something, all I'm asking you to do is draw the mirror image. Again, enantiomer, non-superimposable mirror image of a molecule. Now, I talked about Fisher projection, which is this. Here, 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 and here are carbons. And those OH and hydrogen are coming out towards you, and the other carbons are going back. It actually shows 3 dimensions. This was created by the great German organic chemist, Dr. Emil Fischer. And he did a lot of work in this, and he also did Fischer esterification, how to make esters in the lab and plants. Now, 2 reactions I even have here, know this, know it. If you take an aldehyde or ketone, react it with an alcohol and acid, you'll get a hemiacetal. Well, here, if you take this alcohol, and when 2 functional groups are in the same molecule, they react better. So this is an equilibrium. You don't need the acid catalyst. And this hydrox group on carbon 5, remember the carbonyl is 1, 1, 2, 3, 4, 5. This is glucose, attacks the carbonyl and forms this hemiacetal here. And you should know this. If I give you this and this, you should be able to write the product. If I give you the product, you should be able to write or name the starting material. And this is glucose. I will not ask you on tests to draw the structure of glucose. Same thing happens with fructose, where here you have your ketone, alcohol, acid, same thing, hemiketal. Here's on carbon 5, the hydroxy group attaches that and forms a carbon-oxygen bond to this carbon. Same thing here. Oxygen-carbon bond to this carbon. That was the carbonyl. It's important to show this bond. Now, once you have the hemiacetal or hemiketal, which we didn't talk about when we did this reaction, aldehydes and ketones, I showed if you reacted it with 2 of the same alcohol. But if you have this hemiacetal or hemiketal and react it with a different alcohol and acid, you'll form this unsymmetrical ketal or acetal. And here's the example. Here's our hemiacetal glucose, alcohol, acid, and this forms this acetal. And this is how glucose connects together to form a polymer, which we call starch. And all of your starches are polymers of glucose with this reaction. Now, you should know sucrose, table sugar, are fructose and glucose bond together. Just the names, you don't have to be able to draw the structure. And like I just said, starch is a polymer of glucose. So if we have an atom acetal and add acid and water, or add acid, first of all, to glucose, you make starch, and the linkage between there is an acetal. And you learned in test number 2, acid and water and acetal breaks it down. So for sucrose, the acid in your stomach, HCl, H plus, and you got water there too, breaks sucrose down to fructose and glucose, and you should know this. And starch, which is many glucose molecules brought together, bond together by acetal linkage, that is acid and water reacts, breaks the acetal, and you get glucose, which is why it's the most abundant sugar and found in your bloodstream, your body breaking down carbohydrates. Now, leaving my class, you should know how to describe with words and a general reaction what happens when you eat a fat or oil. Again, leaving my class, you should be able to describe with words and a general reaction what happens in your stomach when you eat a fat or oil. Well, in words, what's the functional group in a fat or oil? An ester. And it's acid hydrolysis of an ester. And here you learn for test 3, acid, ester, acid, water, H plus is any acid. And you get back the carboxylic acid and the alcohol you would have used to make that ester. Eating a carbohydrate, you should know, leaving my class, how to describe with words and a general reaction what happens when you eat a carbohydrate. And the functional group that holds together glucose molecules in a carbohydrate is an acetal. And in your stomach, acid and water, so it's acid hydrolysis of an acetal. And here, the general reaction I taught you for test 2, acetal or ketal, acid and water, get back to ketone or aldehyde, plus the alcohol. And if you want to put a little 2 there, you can, you don't have to. And the alcohol you would have used to make that acetal or ketal. So you should know, leaving my class, how to describe with words and a general reaction. First of all, what happens when you eat a fat or oil? And that's acid hydrolysis of an ester. And the general reaction is, you learn for test 3, ester, acid, water, you get back the carboxylic acid plus the alcohol you would have used to make that ester. All right, part 2, or not part 2, the second reaction you should know, leaving my class, is when you eat a carbohydrate. What's the functional group that holds glucose together in a carbohydrate? An acetal. In your stomach, acid and water, so that's acid hydrolysis of an acetal. And here we have an acetal or ketal, acid and water, and you get back to ketone or aldehyde plus the alcohol you would have used to make that. With that, I'm done. Remember, hand in labs. Remember, the deadline for the optional extra credit project is this May 1st, Thursday, by the end of the day. And don't forget, on this Thursday, May 1st, I will be giving test 4. Oh, I got my finger fixed. Yep, yeah, it's fixed. Wow. I'll be giving test four. Oh, it's broken again. I'll be giving test four on 8 a.m. or sooner Thursday morning. I'll email out the PDF file with the password or the password for the PDF file. And then you have until Friday, 8 p.m. to upload your answers as a single PDF file. If you have any questions, always feel free to email me, or if you need help, see if I can set up a Zoom meeting to meet with you. And with that, I'm going to say, gang gesund, which is Yiddish for going hell. And you know what I'm going to do next. Bye now. Stole that from Granny and the Beverly Hillbillies. Bye.